So in this numerical, the center distance is given. The center distance between two gears is 106 mm. Then the module is given. So module is indicated by small m. It is given as 3 mm. And they have given the gear ratio, the ratio of the speed of the driver to the driven, or the gear ratio is given. The gear ratio is 2.2 as to 1, means 2.2 upon 1. So now we need to find out the number of teeth on pinion, so let it be small t, and the number of teeth on gear, let it be capital T. Now the center distance is the distance between the centers of the two gears, so it will be equals to the radius of pinion plus the radius of gear. So if we are going to consider a gear pair, the smallest of the two is pinion and the largest is the gear. So here gear number 1 is pinion and gear number 2 is wheel or gear. So the center distance is the addition of the radius of pinion plus the radius of gear. So why I have written the center distance formula as small r plus capital R. Now we know that m module is equals to d by t for pinion. Module, we have seen the definition of module. Module is the ratio of the pitch circle diameter of the pinion or gear upon the number of teeth on pinion or gear. So for the pinion, the module will be d by t. Remember over here, the module for any two machine gear is always same. So the module is d by t. So if I want to find out small d, it will be m into t. Now the radius will be equals to d by 2. The radius of the pinion is d by 2, hence it is mt by 2. Similarly, if we want to find out the value of capital R, so module is capital D upon capital T, the pitch circle diameter of the gear upon the number of teeth on gear. So module is same, module is not going to change. So capital D is equals to m into capital T. So capital R will be equals to capital D by 2, hence it is m into capital T by 2. So we are going to write the center distance formula in terms of the values of m and t. So small mt upon 2 plus capital MT upon 2, small r plus capital R. So now we have got m by 2 is common into bracket small t plus capital T is the center distance. Now the center distance is given as 106 mm. So 106 is equals to module is 3 by 2 into small t plus capital T. But now in the given data, the gear ratio is given as 2.2. So now the gear ratio is the ratio of number of teeth on gear upon number of teeth on pinion. So remember this, the gear ratio is the ratio of number of teeth on bigger gear upon the number of teeth on smaller gear. So number of teeth on gear or wheel upon number of teeth on pinion. So it is given as 2.2. So we do know that capital T is equals to 2.2 times of small t. Put this in above equation. Put the value of capital T in above equation. So 106 is equals to 1.5 times small t plus 2.2 capital T. So over here 106 is equals to 1.5 into the addition of this, sorry, here it is small t, so it is 3.2 small t. So 1.5 into 3.2 is 4.8 times of small t. So small t is equals to 22.08 is the value of small t, but it is not possible to manufacture the teeth with some fraction. Means we need to round off this value. Either we will need 22 teeth or we will need 23 like this. So we need to round off this value. So let small t value, we are going to round it off to 23. So 23, if small t is 23, then capital T from the A equation, capital T will be, so 23 into 2.2, it is 50.6. So it is not possible to have 50.6. So this will be our trial 1. As we are not getting the complete integer, so we'll proceed for trial 2. In trial 2, we'll consider small t as 24. So 24 into 2.2, it is again, we'll give the value of capital T as 52.8, which is again not acceptable. So again we'll proceed for trial, next trial, so trial 3. So for trial 3, we'll consider small t as 25. We'll consider small t as 25. So 25 into 2.2, it is 55. So we are going to consider the value of small t as 25 and capital T as 55. Means the number of teeth on pinion will be 25 and the number of teeth on gear will be 55.